My name is Alek Vizmeg, and this is my mock full-time interview presentation. So to start, a little bit about me is I'm currently a full-time student at the University of Cincinnati. I'm currently pursuing a Bachelor of Science in Chemical Engineering along with my Master of Business Administration through the university's Ascend program. A little bit about my previous work history is I worked 4 co-ops to date. My first co-op was with a power transmission company called Regal Rexnord, where I worked to develop custom conveying solutions for the beverage industry. My next 2 co-op rotations were at a specialty chemicals company called Ingevity. There I worked on a lot of process improvement projects, some environmental compliance projects, and helped with the commissioning of new equipment. My most recent co-op was with the company called Greif. They're a packaging company, and I worked at one of their paper mills in Columbus. So I'm also a part of UC Club Swimming. I've been a member since my freshman year at college, and I'm currently the treasurer for this season. Outside of school, I like to foster cats, so I've been fostering with Ohio Alley Cat Resource since 2021. Since then, I've probably given about 12 to 14 kittens a home before they got put up for adoption. And then I'm also into a lot of outdoor activities. I like to rock climb, backpack, hike, and mountaineer. And so these are 2 pictures from some of my most recent mountaineering and backpacking trips. So to get into my technical project, this was a project I worked on while I was at Ingevity, and the main goal of this project was to reduce the waste coming off this preliminary screener before I went to our belt dryer to dry. So the product we created at Ingevity was activated carbon, and this plant created them in the pellet form. And so during the process, these particles break up, and smaller particles are prone to falling underneath the belt in the dryer. And if they build up underneath there, it becomes a large fire hazard. So this screener was put in place to prevent the buildup of the particles underneath the dryer. And so to better understand this problem, I collected samples over the course of a few weeks of the off-size coming from the screener, and they were tested in a lab to determine their particle size distribution. So before I started the project, I started with the main issue, which was that usable products were being screened out and not included in our final product flow. The main reason for this was because the screen size in the preliminary screener was too large. This was caused because there was an incorrect initial setup of the screen because we had very minimal information about the belt dryer screen. We didn't know the size, and this was because the belt dryer was bought from China, and so there's a language barrier as well as just poor contact in general with the vendor that we bought it from. So the first step, like I said, was data collection. This is just a sample set of my data, but I collect the data over the course of a few weeks to understand the distribution. And so once I figured out the belt dryer screen size, which was a 20 sieve, I found the portion of our samples that were over a 20 sieve and under the 6 sieve, which was to screen out the large chunks, and this was the portion of the offsize that could actually be included on the belt dryer. So once I collected this data, to better understand the project, I contacted our stakeholders, which was the production manager, the maintenance supervisor to actually make the change on the screener, and the plant manager to ensure that this change would be cost effective. And so the potential solution was to replace the screen in the preliminary screener to match the same sieve size as the belt dryer screen. And so once we determined that about 50% of the particles that were being screened off could actually be included in the final product flow, a new screen was purchased and we notified maintenance of the necessary change. One of the big pieces of this was ensuring that there were spare screens to be purchased, because these screens were often prone to being warped or broken since they were just small stainless steel meshes. So based on the product flow and the 50% of the product that could be included on the belt dryer, it was determined that this change would create up to $65,000 of savings per year. And so this made the project worth it because relative to the savings, the screens were very cheap. And so the next steps to ensure that this solution would work was to verify that the change of the screen did not impact the buildup underneath the belt dryer. Like I said, this is a large fire hazard, and there have actually been issues in the past where a fire's broken out underneath the dryer and damaged the equipment. So one of the big things I learned through this project was to um, take the necessary steps to understand the overall issue, understand what was happening and why it was happening, run some tests to gather data and further enhance that understanding, and then from there, present it in an organized manner to the stakeholders so that the change could be made and that they could understand the savings that could be made from this.